So, yes. So 7 o'clock Pacific time on Tuesday, October 27th. So that's this coming Tuesday at 7 p.m. Pacific time. I will be on kmud.org, where you can listen to it online, right? And yeah, I'm not sure where it's out of. I'm going to guess Humboldt College, but I might be wrong. Or Humboldt University. I might be totally wrong. But I'll alert you guys again on Tuesday. Probably I'll give you a heads up. Anyway, so that's right. Osama, kmud.org. That's right. Doom on the radio, guys. Tune in to Doom on the radio with me and Kelly Lincoln. So yeah, I'm going to play you these clips, and hopefully I've got them lined up correctly, and hopefully you all can hear correctly. Let me know if there are any problems.
More Fukushima water that the Japanese are preparing to pour just a blank load of radiation into the ocean. What's going on with this?
Yeah, this issue has been going on since 2011. So they use this cooling water to try to keep the melted cores cool. And once they get it out of the cores, they put it in these storage tanks. And so what they've got at this point is over 300 million gallons of highly radioactively contaminated wastewater. And one of the main contaminants is tritium, which is radioactive hydrogen, which cannot be filtered at an industrial scale. And the Japanese government and Tokyo Electric are proposing to simply dump it in the ocean. And the only thing stopping them is the fishing cooperatives of Japan, who are like the little Dutch boy with their finger in the dike.
Wow. What's the half-life of tritium?
It's 12.3 years. So that's 123 years of hazard. And the fishing cooperatives, and I should say that, you know, allies across the world have joined them, hundreds or thousands of environmental groups, for example. If the wastewater were to be stored for 125 years, the tritium would dissipate, which is very good news. It's what the fishing cooperatives are calling for. Don't pollute the ocean. Because what would happen, as giants in this field like Rosalie Bertell have long warned, it doesn't dissipate in the ocean. It reconcentrates in the seafood supply, and humans are at the top of that.
Okay, I think that's the end of that. One, I'm going to play you. So they're talking about Fukushima, and I'm going to play you another clip. They're talking about another nuclear plant in Michigan that is having problems, and he's going to go over that.
Tell me about the Cook reactors. These are near Chicago. Do I have that right?
Directly across Lake Michigan from Chicago. It's in southwest Michigan, Bridgman, in Berrien County, Michigan.
Okay.
Directly
what's going on with these things?
Well, for a long time, the Nuclear Regulatory Commission has been in regulatory retreat, and it's just grown worse under the pandemic. Now they use the pandemic as an excuse to skip repairs, to skip inspections. And what's happening at Cook right now, similar to what happened at Davis-Besse, Ohio, back in 2002, is they're finding boric acid crystals on the top of the reactor lid. It means they have a leak, and they don't know where the leak is coming from. And what happened in Ohio 18 years ago was a giant crater got corroded into the lid of the reactor vessel and nearly burst. It would have been a meltdown. It was the nearest miss since 3 Mile Island. Now they're playing games with the same kind of situation at Cook, taking very optimistic assumptions that the leakage is from certain places and not others, risking another corrosion hole in the reactor lid at Cook as we speak. Simply not doing inspections because there's insulation in the way, there are visual impediments to doing the inspections, and for convenience sake, they're just skipping the inspections.
So, yeah, that's happening. So we have, ongoing nuclear crisis, radiation crisis going on. I know some people like to think that it's not all that bad, or, you know, it's not that big of a deal, or nuclear is going to be the way out of the climate crisis, or it's going to be our path to renewable energy. The problem are these problems right here, is that we seem to run out of the money or the time or the facility to keep these power stations in good repair, right? And they don't have a long life. In fact, I think their service life is shorter than it takes to decommission them, right? Am I right on that? I think I am, right? So they're supposed to operate for like 20, 30 years or something like that. Maybe 40 is their operation life. But it takes like 50 or 60 years to decommission them. So that the math right there seems to be not just a problem, but just short-sighted in the ideas around how this is an actual viable energy source, and it is not. And obviously, if there are less humans around to take care of these things, or if we have an economic collapse, if we reach some kind of economic tipping point where, you know, the people that keep these things going or running aren't able to come into work, or just aren't around, or can't do the job, then you know, what do you think is going to happen then? I'm going to give you a hint. It is not good things. So, yeah, I don't really know what else to say about that. You know, this is, you know, this is a point that Guy Mcpherson brings up a lot, you know, or brought up a lot in his talks that I think everybody has seen, you know, that this is, you know, one of the potential kind of you know, end of the roads, right, for human civilization, and not just human civilization, but all life on Earth, right? So when climate change rears its ugly head and things begin to collapse, economies collapse, industrial civilization collapses, we will not be able to keep these things running. And, you know, when that happens, it's kind of game over. And by kind of, I mean is. Exactly, Donald McCarthy, who's minding the nuclear, chemical, and biological weapons again. World Rope Lamppost, the reactors already exist, so we have to train the future nuclear scientists. Aha. It's a vicious cycle, right? Osama says, it is the 40-plus year inventory of waste that is the problem. It was only supposed to remain at the plants for 3 to 5 years and then on to an impenetrable tomb. That never did happen, did it? Right. These impenetrable tombs that they've built always succumb to what? Natural forces or time. So there it sits, being racked in tighter and tighter, 1,000 plus, racked in tighter and tighter, 1,000 plus isotopes of the most devastating radiological toxins dependent on the power grid for cooling well into the future. Yeah. Yep. Rich Diana, again, yes, takes 40 years to decommission, but the real threat is so many reactors are on a shore or on a riverbank. Remember, there's a nuclear reactor in Omaha that came very close to flooding. There was, you know, major floods. They seem to happen every single year now. But I think it was about 2 years ago, maybe 3 years ago, that there was a flood in the area. And whatever river right there that it's on, Missouri River or Mississippi, I don't know. Maybe I'm way off. Maybe it's another river completely. But whatever river that plant is on, it started flooding, and there was it got very close to overtaking the wall surrounding the plant. So yeah. That could happen. Also, remember in Phoenix, there's a nuclear power plant that's cooled by wastewater from Phoenix. Gee, that's one of the most brilliant ideas I've ever heard in my life. So when Phoenix becomes a dead husk of a city, which could happen really quickly, what happens to that nuclear power plant? Yes, G. Demarest. Yes. Anyways, let's move on. So here, this is, we've kind of touched on this a little bit over the summer. And again, going back to the Mcpherson paradox, or Guy Mcpherson's earlier prediction this year that that because of the coronavirus and the downturn in emissions, the economic downturn and the downturn in emissions, that we would get a huge spike because of lack of global dimming, that we'd get a huge spike and then, the end of the world, and then we're all dead this year. We're all still here. So just on a very cursory, glance at the planet, that did not happen. And then, a lot of people were discussing at the very beginning of coronavirus that there was going to be a huge spike in temperature, global dimming. We would lose all the aerosols. And, people were wondering about that, rightly wondering about whether or not that was going to happen. And so, we haven't regained full, I don't think, like air travel is not back to where it used to be. Not everything is operating at 100% again, but we're kind of ramping back into normal industrial civilization. However, we did have a big dip for a while, and that whatever temperature spike was supposed to happen, I don't know, didn't really happen. It didn't look like to me. And so I had a question about the veracity or the actuality of global dimming, or what's the actual threat of global dimming or the aerosol masking effect. And I'm not there's been plenty of studies on it. I'm not discounting the effect for what it is. I'm not discounting the fact that I'm sure it's in play on some level, but again, we didn't get taken out. And the heating that has happened this year, I think, is, as we've seen the charts and the graphs and all of that and the temperature data, it looks like, yes, temperature is increasing, but like on the level, on the trend line that we were at, there was no just huge spike this year just because of coronavirus. It was just, yes, it's going up and it's continuing going up, and it's going to continue going up, but maybe not on the spike level of what was supposed to happen if we lost the dimming effect, right? So Jazz Farm says, I would argue the reduction of dimming is just slower. The heat here in the West in the last 10 months has been pretty nuts. Yeah, I mean, there has been heat, but again, like not, this summer was hot in Southern California, but not maybe not as hot as it was, not to the level it was like 2 or 3 years ago. So, we've been seeing we've seen hot weather, heat waves, they've been happening, but kind of like in line with how it's progressing. Anyways, so, it got me to thinking that, maybe the masking effect is there. Maybe it takes longer to kick in. I don't know. I have questions. That's all. I don't know anything for sure. I'm not doing the studies myself. I'm just trying to look at whatever data is coming my way, if there is any data, or look at just, the overall consequences of what has happened over the last 6 months. And, maybe it isn't what it was all chalked up to be. I don't know. Anyway, so check it out. So Mcpherson himself, on his morning headline show today, referenced a paper, and here's the paper. It's from Geophysical Letters. Now, he questioned, how seriously we should take this paper. And, sure, rightly so. Like, is this the end all be all? Is this the, what we should base all our future actions on? Probably not, but it's just an interesting data point, or at least an interesting, addition to what we have so far. Anyway, so this is from Geophysical Research Letters. Minimal climate impacts from short-lived climate forcers following emission reductions related to the COVID-19 pandemic. So this is great. Guy also referenced another paper in Science. Look, I got this right before my show, so I couldn't actually really research it all that well. I only could just get what he said the title of this paper was. So this is the only thing I could reference. I couldn't really find the other paper from Science, so I'm just reading this to you now, and we can discuss this, in the future. So anyway, so this is I was waiting for somebody to do some kind of, report or study on the effects of climate forcers or emissions or global warming or aerosol masking effect on, all that due to COVID-19 pandemic. So here we go. Just going to read this. We present an assessment of the impacts on atmospheric composition and radiative forcing of short-lived pollutants following a worldwide decrease in anthropogenic activity and emissions comparable to what has occurred in response to the COVID-19 pandemic using the global composition climate model, United Kingdom chemistry and aerosols model. Emission changes reduce tropospheric, hydroxyl radical and ozone burdens, increasing methane lifetime. Reduce SO2 emissions and oxidizing capacity lead to a decrease in sulfate aerosol and increase in aerosol size, with accompanying reductions to cloud droplet concentration. However, large reductions in black carbon emissions increase aerosol albedo. Overall, the changes in ozone and aerosol direct effects, neglecting aerosol cloud interactions, which were statistically insignificant, but whose response warrants future investigation, yield a radiative forcing of -33 to -78. Oh, and I don't even know what this is. Is it meters to watt meters? I don't know. -2. Anyways, sorry for my lack of understanding what that equation is. Anybody can see that, please let me know. Upon cessation of emission reductions, the short-lived climate forces rapidly return to pre-COVID levels, meaning these changes are unlikely to have lasting impacts on climate, assuming emissions return to pre-intervention levels. Plain language summary is, as a result of global COVID-19 pandemic, unprecedented lockdown measures have been imposed worldwide to reduce the spread of the disease, causing huge reductions in economic activity and corresponding reductions in transport, industrial, and aircraft emissions, as well as lowering emissions of greenhouse gases, such as carbon dioxide. That has resulted in a dramatic reduction in the emissions of pollutants that also affect climate. In this study, we have used state-of-the-art computer simulations to quantify how changes in these components are likely to impact the chemical makeup of the atmosphere and the likely short-term impacts on climate. Despite large decreases in nitrogen dioxide and atmospheric particles, we find these changes result in a very small impact on the energy balance of the atmosphere, but one that would act to cool the planet without considering the knock-on impacts on clouds, which we cannot be confident about. However, these impacts are all likely to be short-lived if emissions return to pre-lockdown levels. So I'm not going to go deeper into that. I'm just reading the overview of that. So, basically saying, were the impacts all that big? Maybe not. Oh, watts per meter squared. Thank you, Lightning Rod. I appreciate that. Guyo Smith, sorry for my lack of hopium. Oops. Yeah, so anyways, when people are talking about solutions to climate change and reducing emissions and, the idea that we can't do that because of the global dimming effect or the aerosol masking effect, I don't know. I have questions. And this was a good moment in time in history for us to actually see what's the actual effect when all these emissions go away for 2 or 3 months, on a large scale basis, globally, China, the U.S., Europe, etc. Right? We have a large scale reduction in emissions globally. Was there a major shift in temperature or climate that was noticeable or measurable? From what I have viewed or seen, I can't see it. I don't know. These are just things that I'm taking in myself. So, okay, take whatever I'm saying with a huge grain of salt. Take whatever my conclusions are, they're just my conclusions, but I just haven't seen it. So, does that mean, does that mean, well, maybe reducing emissions is not the horrible, terrible thing that, has been laid out for us? Anyways, are we going to actually reduce emissions? That's the other question. Probably not. Probably not fast enough. Probably not in time. So, there's a whole lot of factors to take in here and to balance or juggle in your brain. So there you go. I will, what I'll try to do is find that science article that Mcpherson was referencing. If anybody knows what he's referencing, if anybody has a link to that article that he's referencing, please send it to me so I can check it out. Kuro Hikes, Trump is the greatest POTUS since Abraham Lincoln. Right. He's also the least racist person in the room. Woo! That was just high comedy right there. That was hilarious. Osama says spray planes are a big factor. Yeah. I mean, there are so many different factors to factor in, to take in. I have no idea. I'm just, just spitballing, but again, I just didn't see the rapid rise in temperature or anything beyond whatever the rate of change it is that we are experiencing right now. I didn't see anything beyond that. Personally, with my eyeballs, who knows? And any other information I can take in about it, I would gladly welcome. If anybody wants to send me a link, I'd love to see a link. Anyways, let's move on. The climate crisis undermines global food security. Yeah? Okay. Do you think? This is from David Wint, tweeted this out. Let's take a look at this. Just quickly. This is from 2019, so a little while ago. But we've been talking about food security. Climate change is leaving crops at risk, driven by global warming, and with it, ever greater extremes of heat, drought, and rainfall. The rising mercury can explain up to half of all variations in harvest yield worldwide. We were just talking about this yesterday as well, how drought and climate change are creating possible future dust bowl and other agricultural problems. Unusually cold nights, even greater numbers of extremely hot summer days, weeks with no rainfall, or torrents of storm-driven precipitation account for somewhere between a fifth to 49% of yield losses for maize, rice, spring wheat, and soybeans. And once international scientists had eliminated the effect of temperature averages across the whole growing season, they still found that heat waves, drought, and torrential downfall accounted for 18% to 43% of losses. So there you go. I'm not going to get too deep into this, but yes, We already know this. We cover this often. Climate change is already, not in the future, not in 2050, not in 2070. Climate change is already affecting yields and the ability to grow. Enough food to feed all the people. On the fence with Muzza, what's going on? How you doing? Welcome. Greetings. Anyways, let's move on. Let's move on to what's happening in the Arctic, because that is a pretty big story. What is happening in the Arctic is that the ice is not refreezing. We have also been covering this here pretty much daily for the last week. So this is from Zach Leib. A historic event is going on in the Arctic. We have to pay attention to these climate change indicators. It's from yesterday. This is Laptev sea ice. Moving on to another chart from Zach Leib. Are you guys seeing this or no? Just making sure you all can see this. Hold on one second. Okay. So yeah, Arctic sea ice departure. 2020's anomaly continues to grow in the Arctic, well exceeding the record in our satellite observations. Graph uses a 1981 to 2010 climatology from NSIDC data, 5-day running mean. So look at where we are in 2020, Arctic sea ice departure, nearing November. We are way down, rock bottom. And then let's move on to this article from The Guardian. Alarm as Arctic sea ice not yet freezing. This is from yesterday. Delayed freeze in Laptev Sea could have knock-on effects across polar region, scientists say. For the first time since records began, the main nursery of Arctic sea ice in Siberia has yet to start freezing in late October. The delayed annual freeze in the Laptev Sea has been caused by freakishly protracted warmth in northern Russia and the intrusion of Atlantic waters, say climate scientists who warn of possible knock-on effects across the polar region. Ocean temperatures in the area recently climbed to more than 5 C above average following a record-breaking heat wave and the unusually early decline of last winter's sea ice. This has been happening, guys, for, we all know this, for the last for sure for the last 3 years, if not the last 5 years, that there's been temperature anomalies, Arctic heat waves. This is why we have all these polar vortex situations going on, because the Arctic is so warm, it's pushing out all the cold air. This is happening in winter and in summer. So we're getting, ice melt, obviously record ice melt, and on some occasions ice melt all year round, or in times when the ice should be negative temperatures going on in the Arctic, and it's almost near freezing or even above freezing. I think it had climbed. The temperature had climbed above freezing a few times this winter in the Arctic, some places in the Arctic. So that's wild. Ocean temperatures in the area recently climbed to more than 5°C above average following a record-breaking heat wave and the unusually early decline of last winter sea ice. The trapped heat takes a long time to dissipate into the atmosphere, even at this time of the year. So yes, someone mentioned the latent heat. Latent heat having to be released. This is why there's a late freeze. Even this time of year when the sun creeps above the horizon for a little more than an hour or two each day. Graphs of sea ice extent in the Laptev Sea, which usually show a healthy seasonal pulse, appear to have flatlined. As a result, there is a record amount of open sea in the Arctic. And again, here's basically the same graph. Zach Labe had tweeted out, the lack of freeze up so far this fall is unprecedented in the Siberian Arctic region, said Zachary Labe, postdoctoral researcher at the Colorado State University. He says this is in line with the expected impact of human-driven climate change. 2020 is yet another year that is consistent with a rapidly changing Arctic. Without a systemic reduction in greenhouse gases, the likelihood of our first ice-free summer will continue to increase by the mid-21st century. Again, with the disinformation or extreme amounts of hopium, talking about we got 30 years of ice left. We do not, Zach Laban. I wish you would, I wish you would stop saying that. Woo! It goes down smooth. This year's Siberian heat wave was made at least 600 times more likely by industrial and agricultural emissions, according to an earlier study. The warmer air temperatures is not the only factor slowing the formation of ice. Climate change is also pushing more balmy Atlantic currents into the Arctic and breaking up the usual stratification between warm, deep waters and the cool surface. This also makes it difficult for ice to form. This continues a streak of very low extents. The last 14 years, 2007 to 2020, are the lowest 14 years in the satellite record, starting in 1979. Said Walt Meyer, senior research scientist at the U.S. National Snow and Ice Data Center. He said much of the old ice in the Arctic is now disappearing, leaving thinner seasonal ice. Overall, the average thickness is half what it was in the 1980s. The downward trend is likely to continue until the Arctic has its first ice-free summer, said Meyer. The data and model suggest this will occur between 2030 and 2050. Okay. Anytime in this whole 20-year frame. Okay. It's a matter of when, not if. Yeah, and, well, we don't even have 10 years, sorry. Sorry, unless something magical happens, unless we get some kind of respite. Scientists are concerned the delayed freeze could amplify feedbacks that accelerate the decline of the ice cap. It is already well known that a smaller ice sheet means less of a white area to reflect the sun's heat back into space. Where am I? But this is not the only reason the Arctic is warming. Hold on one second. Not the only reason the Arctic is warming more than twice as fast as the global average. The Laptev Sea is known as the birthplace of ice, which forms along the coast there in early winter, then drifts westward, carrying nutrients across the Arctic before breaking up in the spring in the Fram Strait between Greenland and Svalbard. If ice forms late in the Laptev, it will be thinner and thus more likely to melt before it reaches the Fram Strait. This could mean fewer nutrients for Arctic plankton, which will then have a reduced capacity to draw down carbon dioxide from the atmosphere, etc., tipping points, feedback loops, etc. More open sea also means more turbulence in the upper layer of the Arctic Ocean, which draws up more warm water from the depths. Dr. Stefan Hedricks, a sea ice physics specialist at the Alfred Wegener Institute, said the sea ice trends are grim, but not surprising. It is more frustrating than shocking. This has been forecast for a long time, but there has been little substantial response by decision makers. Rightio. Oh, I forgot to say this, guys. So, got to do my Gaslight Friday public service announcement for Black Bear News. We have 124 watching, 56 likes. Please like up the video. If you are new, please subscribe. So YouTube unsubscribes people all the time. I now have more followers on Rockfin than I do on YouTube. That's because YouTube suppresses me like really hard. They really don't like my channel. So if you could, please make sure that you are still subscribed. If you thought you were subscribed, they kick people off the channel all the time. Please resubscribe if you have been kicked off. And also, let's do a subscriber push today, a big push today. Let's get as many people subscribed today as we can. Let's push it up greatly so we can overcome the algorithms and the bots. Thank you so much. So lastly, today, I just wanted to look at this. Staying in the Arctic with weird techno utopian plans to refreeze the Arctic. This article is from a year ago from Brian Kahn in Gizmodo. Turns out a wild geoengineering plan to refreeze Arctic sea ice isn't the best idea. Really. So people sometimes like to bring this up or like to talk about it or like to float it. As the world spins closer to climate catastrophe, fringe ideas are inching towards the mainstream. Geoengineering is among the topics that were once verboten but are now finding traction, and that includes some pretty out there ideas, including one focused on saving polar ice by pumping massive amounts of seawater onto the surface of the ice where it will refreeze quicker and strengthen all ice pack against melting. You all heard of this one? You heard of it? The refreezing idea has been proposed for both poles and would be massively expensive. But a new study shows that in the Arctic, saving sea ice would do little to slow the climate crisis elsewhere. And it would unleash shocking and unintended consequences in the Arctic itself. Remember the story we read a couple months ago about the lady that was trying to develop little silicone balls? Maybe it was last month. Little silicone balls to spread all over the Arctic so it'll refreeze. Yeah. The paper published in Earth Future on Thursday takes its inspiration from a previous study that first raised the prospect of an Arctic geoengineering project. The study outlined a proposal to install wind turbines across the Arctic that would power pumps to draw water to the surface of the remaining sea ice, where it would refreeze more quickly than from the bottom up. Sounds a little bit okay, a lot radical to be sure, but the rapidly warming Arctic needs all the help it can get. Old sea ice that used to hold the ice pack together is all but gone. It's out of here, folks. It is gone. And we could see an ice-free Arctic as early as the next decade, or even this decade, if you're trying to stay in reality about where we're at. I know it's hard. I know you don't want to. I know it's scary. I know it's uncomfortable. But let's try and stay in reality, please. If carbon pollution isn't slowed soon. But while the previous research showed it was technologically feasible to do the wind turbine thing, it didn't look too hard at what the climate ramifications would be. Nope. The new paper picks up at that point because, as Lorenzo Zampieri, sounds like the guy that invented the ice machines for hockey rinks. What are they called? Those are called Zambinis or something. Zampieri, the new study's lead author and PhD student at Germany's Alfred Wegener Institute, told Earther this geoengineering idea had never been tested with a climate model, and in our opinion, this was a necessary step to contextualize this approach. The scientists used an advanced climate model to explore what the scheme would actually do to the Arctic. They modeled a number of scenarios, including one idealized scenario in which seawater was pumped over the entirety of the sea ice. That model found that ice would grow up to 65 meters. Woo, that's a lot of meters. Thick over the rest of the century. A huge change from the average historical thickness of 1.8 meters. Or 6 feet. Anyways, they dialed things back a bit more to a realistic scenario that aimed For an average thickness of around 2 meters, a little over 6 feet, and moderately spaced out windmills and pumps, the good news, it would indeed help refreeze. But the less good news is that the process would radically alter the climate in the Arctic while doing very little to fix the global climate overall, not to mention all the lovely destruction we're doing, deforestation we're doing, emissions we're pumping, things we're putting in the soil, pesticides and fertilizers and all that, et cetera, et cetera. Healthy carbon we're pumping into the ocean. Healthy reflective ice that lasts through the summer would restore the late summer Arctic climate to some semblance of its former self. Pumping throughout the winter, however, would result in an unintended warming for parts of the Arctic in the latter half of the century. That's because as the ice freezes, it releases energy in the form of heat. Layer that on top of the warmth from global warming, and you have a recipe for a very confusing Arctic winter. Oh, and speaking of that global warming, while saving Arctic sea ice is great for polar bears and the people who live there, it does just about jack shit for the climate globally. The mid-latitudes where most humans live would see just a few hundredths of a degree of cooling as a result. That's nice and all, but it ain't going to do much to save the coral, stop wildfires from burning out of control, or keep people from dying. This type of modeling will be crucial in the coming decade to understanding the options we have on the table. Other forms of geoengineering, like blocking sunlight or undertaking massive reforestation projects to suck carbon out of the air, are also gaining steam as the climate we so rely on keeps unraveling. There's a seductiveness to thinking we can just implement a few techno fixes to buy time while the world gets its act together, drawing down emissions. But the reality is that they will almost surely come with trade-offs and gnarly surprises of their own. I would like to point out that according to our findings, this approach could only buy some decades to the Arctic sea ice, while a permanent solution can only be achieved by reducing the excess of greenhouse gases in the atmosphere and cooling the climate, Zampieri said. That's right, the best thing we could do for the climate and future generations is the one the world has so far failed at, right? The one we're not really trying to do. We say we want to do it, and we think we want to do it, and we got a whole bunch of plans and ideas about building solar plants and wind turbines, but yeah, it might not be as sexy as building huge wind turbines in the Arctic, but it damn well gives us a better chance at survival. Okay, well, you know, drawing attention to the fact that the techno fixes, you know, even the techno fixes we think are all the really cool ones and the good ones, you know, like driving electric cars, probably not the best idea. Hey guys, remember to like, share, and subscribe, and you can support the channel at the links below, PayPal, Patreon, Square. Also, if you'd like to watch the live streams, you can watch the live streams on my Patreon channel. You can subscribe for as little as $1. So hopefully I will see you over there.